our speaker for this session is Dr. Gaurav Chandra Srivastav, TSN Manager, PCR, INSC, Allnex. Dr. Gaurav Chandra Srivastav studied chemistry and obtained a bachelor's and master's degree in chemistry from Kanpur University with over 17 years of prolific experience in the paints, coatings, and ink industry. Dr. Gaurav brings expertise in physical chemistry, chemical reactions, and reaction mechanisms with his role as new formulation developments, raw materials, and synthesis development. Ladies and gentlemen, please give it up for Dr. Gaurav Chandra Srivastav. It is such an honor to have you here, and over to you for your presentation.
Yeah, good afternoon, everyone. This is the presentation on the emerging technologies in powder coating, and especially on the unconventional substrates, which has been now introduced in powder coating industry, and there is a demand from the market for some kind of substrates like plastic, MDF, wood, nylon, PA6. These kinds of substrates are coming up, and powder coating is being used or coated on these kind of substrates. So this is the presentation all about the emerging technologies which we can use on these kind of substrates. So the whole agenda of this presentation is like, there is an overview of Allnex resins, then the trends in the powder coating market, emerging technologies, what are the emerging technologies, what are the unconventional substrates, low bake, fast cure, LTC powder coating systems, then UV powder coating system, and this is a new one, ultra low bake ULB Accure novel powder coating system. This is a latest development in powder coating industry. So this is the overview of Allnex. Most of the people, you might be using liquid or in powder form, the polyester resin, liquid resins from the Allnex additives. So Allnex is the leading producer of resins, additives, cross-linker for various industrial coating resin applications like liquid. In performance resins, we have radiation curable resins, cross-linkers, powder coating resins, and this is the whole complete portfolio. And we are the global player with 2.1 billion euro annual sales. And this is a very leading product profile from Allnex. Allnex is the global leader in industrial coating resins with R&D, sales, and support capabilities across the globe. As you can see, we have technical service centers, we have regional hubs all across the globe, formulation development centers and technical service areas for meeting the specific demand of those areas. Now, we have 23 technical centers across the globe, including joint ventures, and we have close to 400 scientists and researchers working on new development, whether it is a product development, this is a formulation development, or any kind of technical services. We have centralized research labs, regional development labs, technical service centers, and the good thing about the Allnex is it has a strong analytical capabilities. Allnex analyzes the problems from the market and develops the product according to those problems to solve the challenges which are coming in the market. So this is the market trend all about. So in powder coating or any coating, first and most thing is the performance enhancement, how you are going to enhance the performance. On the basis of that, any resin manufacturer or any kind of coating developer develops a kind of product. Second one is regulation and sustainability. Nowadays, we are talking more about the regulations, different kind of EU regulations, different type of REACH regulations, and the sustainability as well. Third one is the functionality. Functionality is most important part of the coating system. You have to develop certain kind of functionalities in the system. Now the cost reduction. This is the most interesting chapter for any coating development. Without increasing the cost, how you are going to reduce its, how you are going to reduce the cost without changing its performance. Now, this is the important thing, penetration versus liquid coating. This is especially for the powder coating segment. Liquid coating has a very vast application field, and powder coating slowly enters in those areas. So what are those areas, how we have to penetrate in those markets, and how we have to cater those kind of requirements which are coming from your customer base or the markets. So in enhanced performance, there are 5 features and different type of coating system. First one is architectural coating system. So there is the a trend or there is the requirement of this kind of coating system that it should have good corrosion resistance, moisture resistance, scratch resistance, self-cleaning ability, flexibility along with the super durable performance, means high weatherability. Now second one is ACE application, yani agriculture and construction equipment application. Here corrosion resistance, weather stability, durability, scratch resistance, multi-substrate adhesion, direct to metal, alkali resistance, and flexible super durables, because these products are out in the open area, always camps in the open area. Now third one is the rail, resistance to cleaning agents, anti-gravity, erosion resistance, and self-healing. These are the features which is required if you are going for a rail coating application. Yeah, this is a general industrial market including coil coating. So DTM, corrosion resistance, weathering, durability, flexibility versus mechanical, means it should have a good flexibility as well as high mechanical properties. Now the self-healing as well. So when we are talking about the regulation and the sustainability, so the demand is for low-bake, fast-cure system, bio-based raw materials, recyclable raw materials, reduced free TMA, tin-free systems, BPA-free or BPA-NI, means BPA-free means it may have some content of the BPA bisphenol A, and BPA-NI means intentionally bisphenol has not been added in any kind of product. So there is a 2 difference. Now the functionality, this is the important thing. When we are talking about for a development for a new coating system, functionality is the most important thing. The coating, what function coating will give to your customer or on any substrate. So special effects, haptics, means soft feel, conductive, anti-static, radar, lidar reflection, self-cleaning, self-healing, low IR absorption, anti-fingerprint, then low dirt pickup and high surface energy. Now when we are talking about the cost reduction, obviously, cost reduction is just not only from the raw material prices. It also includes the amount of coating that has been deposited on the system, on the substrate. Then second point is, what is the time taken during all these kind of activities, means from starting to the end of a production process, how much time it is taking. So thin layer, single layer versus multiple layers, broader application window means time, duration. Then affordable resins, obviously, affordable resins means here the cost of the resin should go down. Then process simplification, faster return to the service, reduce pre-treatment, easy to clean, easy to recoat, or easy to strip, or multi-substrate adhesion. Means you design a coating which gets adhesion on multiple substrates. Now penetration versus liquid, means where powder coating must penetrate, or what are the new areas that are coming for as a challenge for the powder coating against liquid coatings. So liquid coatings are widely used on MDF, solid wood, plastic, coil and can. So these are the areas where we have to penetrate as a powder coating manufacturer to develop all these type of coatings for these kind of substrates. So MDF, solid wood, plastic, coil and can. So till now plastic and MDF has been done. Solid wood is still a challenge. So these are the emerging technologies, these are the new technologies which has come in the market over quite few years. So first one is low bake, fast cure, LTC powder coating. So these are the curing temperatures. A powder coating is defined on the basis of its curing temperature as well as on the chemistry that has been used in the system. So 160 degree 10 minutes, 140 degree 10 minutes, 130 degree 10 minutes. All these are achievable in the powder coating as a low temperature cure system. Then second one is UV powder coating. This is the new one. UV powder coating, 100 to 30 degrees centigrade IR temperature is required for the melt and the flow of the powder. And that is only for 1 to 3 minutes. And post that, once the flow and level have achieved, we pass it through the UV EB cure lighting, means UV curing system, and within a few seconds your system has cured, means the film is cured. So it takes a very less time as compared to conventional powder coating system. Now this is the very interesting thing. This is a ultra low bake ULB powder coating. It is also called Accure technology nowadays. And with this coating, 100 degrees centigrade for 8 to 10 minutes is possible. This technology is IP protected. With this technology, we can reduce the curing temperature to 100 degrees centigrade. So this is a very, what I say, means it's a phenomenal jump in the coating curing system. Now the unconventional substrates. We know we usually do powder coating on metal substrates. So what are the unconventional substrates that has come in 5 years of span for powder coating? So first one is wood. In wood, MDF, solid wood and fiber boards. So these are engineer boards and solid woods. So till now, solid woods has not get that kind of finish as you are getting in liquid finish. But yes, for MDF, any kind of finish is possible for powder coating. We are still doing work on fiber boards as well, because fiber boards has a low charging tendency, so it accepts charge so we need a kind of conductive primer on the top of that, then we have to follow by the powder coating system on it. Now the second one is the plastic, nylon and PSX. These are the requirements from the automotive industries. And yes, we have got a success on this kind of system to achieve a very good finish. So why we require a low temperature cure powder coating? What is the requirement? Because we have thermally sensitive substrates, means the substrates which are very much prone for the distortion to higher level of, if you provide a higher level of thermal energy to the substrates. So simplified forces for the industrial wood, design freedom for the complex slab components in MDF and furniture and cabinetry, shift in the regulatory policy. This is most important thing. Nowadays, there are regulation to shift from solvent-based system to high solid solvent-based system to powder coating. So there is a regulation to reduce the amount of VOC which we are supplying in the environment with liquid coating. So this is a very challenging and this is a very interesting thing, that nowadays we can have a powder coating which can give a very good glossy finish, matte finish, as well as texture finish on MDF board. So this is a very huge market where any powder coating manufacturer can penetrate and go with that. There are the substrates which are heat sensitive. There are metal sheets which are very thin in the thickness, means there are very few mm is available. So for that, if we provide a high amount of heat energy to that substrate, it may change its shape. So we require a low temperature curing system so that we should not get a 180 degree, 200 degree temperature to a substrate, rather than we can do this at a 130 degree centigrade. So this is again slow to heat components. There are components which have a thicker sheets of metal, means high thickness of metal is there. So they take energy very less. Heating is very less on the thermal profile. So on the top of the surface, you are getting the desired curing temperature at a very slow rate. So if you are using your normal coating system, means normal powder coating system which cures at 160, 180 or 200 degree, so it will take time to get cured, because we require an optimum surface temperature for any kind of, means curing of powder coating. So LTC is required for that kind of coating system. By this, we can coat big machines, big components in one shot. So massive metal components which are slow to heat and take longer time to cure, and that's why they are consuming time and energy. So when we lower the curing temperature, it means these components can be coated faster and we achieve a faster production cycle on this kind of, with the help of LTC. The lower coating temperature means LTC. LTC also improves the efficiency of the applicator. The coating side means now the production side is more efficient. It can produce more components in a day. And it also, there is one important point. It also saves the energy. Energy is one of the most important things. Nowadays, Europe is facing an energy crisis. So, the raw material prices and everything are now eventually get affected with all these kind of things. So, if you can give some sort of relief to your applicator on this part, it will be a great help for them. So, these are the challenges while you are designing or while any manufacturer of the resin designs a low curing temperature system. These are the challenges which he has to face. First one is the workability. The most important thing is the workability. In workability, we have to think over two main important parameters. One is the stable storage, means storageability. Means if we produce a powder, can this be stored at the normal temperature? Second one is safe extrusion. If we are giving you a low temperature cure resin, and while the time of extrusion, it gets partially cured in your extruder, then there is a problem in the finish of the final paint. So this is the most important thing which we have to work on. And yes, Allnex has done a very successful work on this. And now these systems are stable, storage stability is there at a normal temperature. Yeah, there are certain kind of products which have a lower TG system, so they require some sort of specific storage requirements, but more or less it is now stable. And extrusion wise also, so the reactivity has been adjusted accordingly so that it does not affect your extruder temperature. Now the second one is the curing cycle. Since when you are having a LTC, that means you are giving a low temperature to any kind of powder coating. So when you are giving low temperature, it gets very less time for the reaction. So we have to increase the reactivity of the components. Second one is faster curing. When you increase the reactivity, it automatically faster cures. So we have to balance out workability with curing cycle to give a sustainable resin for our customers. Now the appearance. These two things affects on the appearance of the final product. So low viscosity, more flow. As you reduce the curing time, the flow of the resin system gets affected. So we have to maintain higher flow in the resin so that with the less temperature, less time, we get a maximum flow on the surface. Now, so these are the challenges while we are designing a resin system or formulating a resin for any of our customer or for the market. And these are also the same challenges you will be facing while you are designing a formulation for your customer. So these three parameters are most important parameters, whether that is for a resin manufacturer or that is for a powder coating manufacturer. Now, coming to, we have talked about the low temperature curing system. Now, this is the second part, UV powder coating. So, this is the comparison between UV powder versus conventional liquid paints. Because when we are going in the market and we are asking our customers that we can use UV powder coating system on your substrate. So they will ask, what is the advantage? So the advantages are easy handling of powder paints, no viscosity control, no dropping. That means powder is 100%, you did not need to reduce its viscosity for spray application or for cut and coating application. So at the time of curing, since powder melts and then flows, whereas liquid flows and then cures. So there is a difference, and we get a dropping effect on the bottom of or the corner of the or the edges of the substrate. Thick film coating is possible with one coat, because in powder coating we can give 80 microns, 100 microns, 120 microns, depending on the surface finish what we need to achieve. Whereas in liquid coating systems, there is a restriction. We have to coat multi-layer, or we have to go for a high solid systems, which have their own advantages along with their disadvantages. Low curing shrinkage, wrapping is less likely to occur in powder coating. No solvent emission. This is the most important thing when we are using UV powder coating or any kind of powder coating, that no solvent is involved in it. So, less prone for any kind of fire hazard during manufacturing as well as at the time of application. In solvent-based system, typically around 50% of solvent is used at the time when we are applying that coating system on the substrate. In high solids, it is 20 to 35%. In water-based, it's around 10%. Then in powder, this is 0%. Water-based, there may be a debate on this because different type of water-based paints have different type of waters. But we are not talking about water here. We are talking about the solvents. So solvents is not more than 10% in any kind of water-based system. So with that no solvent emission, we get much less toxicity concern. There is no free monomers, no VOC, nothing is we are releasing in the atmosphere. So it is a 100% green technology as per the terms of VOC. Now, no solvent incinerator equipment is required. Means if you have a closed environment, then you require some kind of equipment, and if you are using certain thinners and this, so you need a certain kind of equipment to recover those solvents. So with the powder, there is no requirement. And even the biggest advantage is over-sprayed powder can be collected and used up to 85 to 90% in the next batches with some mixing with fresh powder and the over-sprayed powder. So the material efficiency is much more, curing cycle is much reduced and less energy consumed. So this is a new, we can say, a step in powder coating industry if we can move ahead towards the UV powder coating. So when we are talking about liquids, these are all the comparison with the liquids. Now we are having a comparison with the conventional powder paints, means UV powder paints versus conventional powder paints. So this is, if we are using convection over, curing temperature is 140 to 220 degrees centigrade, time is 15 to 30 minutes. This is the metal. The time may vary as per the thickness of the metal. The similar IR plus convection, the timing may reduce to 10 to 25 minutes, depend on the thickness of the system. Then IR, 160 to 250 degrees at 5 to 15 minutes. This is for the metal substrates. Now, when we are talking about the UV powders, most important thing, you require heating only for 1 to 3 minutes. And that is with the IR. So IR or in the convection, we require 1 to 2 minutes or maximum, in maximum case, 3 minutes of heating to melt the powder and flow on the substrate. Then when you pass it to the UV or EB light, it cures within the seconds. So now the total timing is somewhere around 2 to 3 minutes, not more than that. And that can be used on metals as well as on wood as well as on plastic. So multiple substrates are available here. So this is the biggest advantage over conventional powder to the UV powder system. So this is the same thing which I said, like a low temperature fast curing system. So means faster productivity, energy efficiency, reduced cycle time, high productivity, reduction in the energy consumption and CO2 emission, or you can say the solvent emission. Now, UV powder coating, potential application substrates. What are the substrates where we can use this kind of? So, heat sensitive substrates which are thermally stable up to 110 to 150 degrees centigrade. So, because we require IR or the convectional heating system for 110 degrees centigrades to 1 to 3 minutes for melting the powder and flow on the surface. So, any substrate which is stable at 100 to 150 degrees centigrade of the range, then can be used, means that can be coated with the UV powder. Like engineering woods, MDF is one of the examples. Plastic, nylon, PA6, there are some engineered PVC as well. alloy, pre-assembled components which have heat-sensitive parts like electrical wiring, rubber seals, etc. So there are components which we need to coat. So that can be coated with the UV system because now you require heat at a lower temperature, 110 degree to 130 degree or 140 degree, depending on the heating system you are using, IR or convection oven. So this can be done. These are some examples of a large mass part, means bigger parts can be coated with this kind of coating system. And now this is the latest development in powder coating industry. This is a ULB Accure coating system. It has a 3-component system, component A, component B, and the catalyst package. All are available with the Ulnex. The binder part means all 3 part resin, its reactor, and the catalyst is available with the Ulnex. Now, what you have to do, you have just to prepare the coating. As per the requirements, you have more experience on pigments, fillers, additives. So we have to do extrusion, create a powder, and curing is possible at 100 to 110 degrees centigrade for 8 to 10 minutes. This is an IP protected system. So if you want to have more information on this, we can have a one-to-one discussion on it. So these are the features of this. Fast reactivity, we can tune the reactivity as per our requirement. Broad design options are available for different kind of substrates. And we have a favorable HSE profile, means there are no hazardous substance. So no leveling is required on this. So potential coating performance, which we will achieve with this low temperature fast cure system, 100 degree curing possible. You can tune this curing profile from 100 to 130 degrees centigrade as per your requirement. Workability is there. That means ease of extrusion is there without hampering your extrusion temperature or any kind of reaction. Then good storage stability at ambient room temperature. Coating performance, chemical resistance, weatherability, all are very good in this. And coating finish versatility, gloss, you can achieve any kind of gloss and any kind of special effects like texture, matte, whatever. With the same resin and coating system, you can achieve different kind of effects in that. So this is the application process for wood, low temperature curing. So furniture materials are these: solid hardwood, wood-based substrates, engineering wood, metal-based substrate, steel, aluminum, plastic, and others. So in wood-based substrates, we have solid wood, solid hardwood. This is, till date, it is not possible with the powder paint because of the porosity available in the system. Engineering wood, plywood, HDF, MDF, plastic board, black board oriented. So these all can be possible with the powder coating with some pros and cons in the surface finish. So most prominent is we have most success on the MDF system. We have achieved a very good high gloss level, good matte level, texture finish, everything there. So the goal is to achieve all these WBS, means wood-based substrate with powder coating. We want to coat all wood-based substrate with the powder coating. So this is our ultimate goal. We till now have reached till MDF and SDF. This is a typical curing and preheat oven layout. So here you will load your MDF board. It will goes for a preheating. This is for LTC. Then this is a powder coating booth. It will get coated, cured, and cooled down, and it is wrapped, and you can supply it. So this is a industrial layout. What are the challenges in that? There are challenges while we are coating a MDF. So we need to understand this. Porosity of MDF. Different type of MDF have different type of porosity. We have to overcome that. Gas evaluation. When you heat any substrate, there is a gas evaluation, means the pore size will open and the gas will come out. Water resistance, adhesion, charging of the substrates. Different type of MDF have different type of charging tendency. Low heat conductivity, surface temperature retention, removal of formaldehyde, and edge cracking. These are the things which we have, which are the challenges in the system. So UV powder coating process, it can be done on MDF as well as on the plastic. So this is, you have applied on the substrate, IR radiation, 100 to 120 degrees centigrade for 1 to 3 minutes. UV curing and cured film. So this is a very simple process. You can go ahead with a very shorter span of production cycle. So this is eco-friendly, no solvent, low temperature cure. Efficiency, it reduces the space and faster line speed. This is from the Alnex. We urge you to participate in the emerging technologies. So with the emerging technologies, it's time for a different step, different direction. Thank you very much.
Thank you so much, Dr. Gaurav Chandra Srivastav. Very well said that it's time for a different direction. Well, I'll now call on stage Mr. Yasser Arafat from Berger, Bangladesh to felicitate Dr. Gaurav Chandra Srivastav. Can I please have you up the stage, sir? Well, Dr. Gaurav, in his presentation, very rightly mentioned about the low bake, fast cure, UV powder coating, and ultra low bake. Thank you so much, sir, for getting us insights about the emerging technologies. I'd request you to felicitate Dr. Gaurav, sir. Thank you so much, gentlemen. I'd request you to be seated.